Welcome everyone. This video is sort of an introduction to what I hope will be a series of videos about the topic of logic. As I said, I hope that I will be making lots and lots of videos about logic, which is a field of math. And to start off, I want to consider an example from literature, a rhetorical device that is called Kafkatrap or Kafka's trap, perhaps. I'm not sure. You could say any of it. I will call it Kafkatrap. And you might have heard of the author Franz Kafka. He has many famous books. And the trap goes on like this. A guy is accused, let's say, of some action. A guy is accused. Someone is accused. So, as we said, someone is accused and they say that I didn't do this. So, they deny it, right? They deny that they did it. And after the denial, the result that the person who accuses comes to is that denial shows that they actually did it. So, they took the denial to be a proof. Because the argument goes like this: denying the action would be what the person who did the action do, right? So they are saying if you have a person who is guilty, a guilty person would deny the accusations. So if you deny, then you should be guilty. That is the thought process, and you can see that this thought process is not that valid. There is a fallacy in this. And what is the fallacy? Well, this is the fallacy. We only know that if you're guilty, then you deny the accusation. But that doesn't translate to if you deny, then you're guilty. This result does not necessarily lead to the one below it, which is what the fallacy is actually about. So why am I telling this? Well, the Kafka trap, the fallacy here, works from the assumption that the case is not like this, but rather like this. We have guilty, and that goes to deny in both directions. So if you're guilty, then you deny it. If you deny it, then you're guilty. This is called a biconditional. This is just a terminology, and we actually get started on logic. So that's nice. This is a biconditional statement. As you can see, there is two heads of the arrow. It points in both directions. These two statements, on the other hand, this and this, they are only conditional statements because they only work in one direction. The other is not necessarily correct. It doesn't need to be wrong, but it is not necessarily correct. Conditional. Alright? Biconditional, conditional. To elaborate more on the idea of biconditional statements, biconditionals, I want to sort of give its definition. So the definition that I know of, and it is perhaps the most elementary definition, biconditional, so a statement. Let's even use the terminology now. The classic way of doing it is we call first statement P. For example, P in this case was that the person was guilty. And the other statement is Q, which was denying the accusation. So, biconditional means it goes both directions. This is equivalent, this is equal to, this is the case when P gives you Q. So this is, by the way, read as if P then Q, you have this. And also, and, I said and, notice that is important. And Q gives you P. So if you have a biconditional relation between statement P and Q, that means if P then Q and if Q then P are both correct. Another way to write and is, let me even erase it and use the other way, which is like so. This is and let me even talk about or, because in the future videos we might need them. This is or. So what is the takeaway from this video? Well, there is something called Kafka's trap, which is a rhetorical device, a fallacy actually, that is assuming if a person denies something, they are guilty, because denying is the action that a guilty person would take. However, biconditional logic does not necessarily apply here. That's why this is a trap. It's a fallacy. Anyways, I hope this video motivates you to further explore logic and watch the future videos. So stay tuned for those. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.